Fulton Tutoring Center's Math 117 workshop. I'm Nidhi Thakkar, and we'll first go over the agenda for today. So we'll go over factorization, finding zeros, factoring a constant out and finding zeros, quadratic identities, and some examples of quadratic identities. So we'll go over each of these topics and do some problems on, like example problems on them. Apart from that, you can follow us on our social media site. Here is a link for our Instagram and Facebook page. So make sure you do follow us there, because there would be regular updates about upcoming workshops and the schedule for the tutoring center as well. So this is the link to sign in to this workshop. So you can sign in right now and rate this workshop later. I'll put, so it would be half on. There you go. All right. So as I said, I'm Nidhi Thakkar. I'm a computer science major. I'm a sophomore right now, and I joined the special programs tutor this fall.
I'm Aishwariya Ranjan. I'm a computer systems engineering junior, and I also joined the special programs team this fall.
Yeah. So the learning objective, as we mentioned earlier, is factorization, finding zeros, factoring a constant out and finding zeros, quadratic identities, and we'll do example problems on those identities. So first we'll go over factorization. We'll start with some basic factorization and then we can level up. So right here we have x squared minus 5x plus 6. So what we have to do here is we have to find two numbers whose sum is the middle one and the multiplication is the multiplication of like the first and the last term. So we want two numbers whose sum is 5 and multiplication is 6, because 1 into 6 is 6. So we have 2 plus 3 equals to 5 and 2 times 3 is equals to 6. So we can split up the middle term here. So we have x squared minus 3x minus 2x plus 6 equals to 0. So these both terms would add up to minus 5, right? So that's why we have it here. So we split it up so that we can factor the common things out. So minus 3x minus 2x, we factored minus 5x into that. And we took out x from here and 2 common from here. So if we take out the x common, we have x and minus 3 left here. And if we take out 2 common from here, we have x minus 3. So now you can see we have x minus 3 and x minus 3, same thing right here. So we have x minus 3 in both the terms, so we can take that common again. So if we take x minus 3 common, what we have left here is x and minus 2. So that's why we get x minus 3, x minus 2 equals to 0. So what would be the zeros of this? So the zeros would be x would be equals to 3 and 2. So this would be the solution for the equation right here. So we can see from here that x would be equals to 3 and x would equals to 2 would give you a value of 0. So this is the first example. We can go over the second one. All right. So we have x squared plus 6x plus 8. Again, we want two numbers whose sum is equals to the middle one, which is 6, and their multiplication or product is equals to 8. So that is 4 plus 2 equals to 6, and 4 times 2 is equals to 8. So we have two numbers, right? We can split 6 into 2x plus 4x. So that will give you 6x right here, as we did in the first thing. So this thing, so 2x plus 4x equals to 6x, right? So we did x squared plus 2x plus 4x plus 8 equals to 0. And from here, what we can take out common is x. So from this thing, we took out x common, and from this thing, we took out 4 common. So we have x times x plus 2, 4 times x plus 2. Again, we can take x plus 2 and x plus 2 common from here. So we have x plus 2 and x plus 4. So the zeros here, so the zeros here would be x equals to -2 and -4. So these would be the zeros here. We can go with the next one. Okay, you can try one for yourself. I'll give you like 2 minutes to do it, and then we can discuss the solution.
Should we put in our answers in the chat?
Yeah, if you're done with that, you can put it in the chat and I can confirm.
Okay.
X plus 4 and x plus 3. Okay, so let's see if that is the correct one. All right. So I think you made a little mistake here. Let's see what you did. We can go over the session.
Oh, I must have put it around, typed it wrong.
Yeah, maybe. It's
yeah.
okay. So we
Sorry
want two numbers whose. Did you get the same one?
Oh yeah, I think I meant to put a -3.
Yeah, it's okay. Yeah. So I'll just go skim over the solution real quick. We want just two numbers, so it is sum is 1 and multiplication is -12. So we get 4 and -3. We split the middle term and we factor it out. So we get x times x plus 4 minus 3 times x plus 4. We take out the x plus 4 common and we get x minus 3, x minus 4 equals to 0. So x here would be, again, x would be equals to 3 and minus 4. All right. So now we can go over another topic. Okay, so what if we have a negative leading coefficient? So if we have a question like negative v squared plus 3v plus 18, what we can do here is factor out -1 common. So if we have the leading coefficient -1, we see that you don't have to check the greatest common factor, but it is good if you have like something else common, you can factor that out also, and it would make your equation more simpler. We'll do one problem of that type also. But right here, we don't have anything that's common between all these three terms. So we just factor out the -1 just to make the first term positive. So if we factor out -1 common, we get v squared minus 3v minus 18. So this is your regular equation, right? Which we solved like in the previous examples. So if we just factor out -1, we get your previous basic equation. And we can simply factor it using the previous method we did. So we'll get v plus 3 and v minus 6. And we usually write it as like, we don't write -1, we usually write it as negative v plus 3, v minus 6. So whenever you have a negative coefficient, the first term, the term with the highest power has a negative, you just factor out -1 and make it into a positive one and solve it like you regularly do. So this was one equation. I have one more for you to try out and let me know if you figure that out. Also, let me know if you're facing some difficulties and we can help you.
All right, I'm almost done. I'm just doing the factoring.
Oh, perfect.
All right, let me just put that in the chat. Make sure I write it correctly this time.
All right, let's see the solution. So we have negative v minus 3, 5v minus 2. Perfect. So here also we can take, we can see that the leading coefficient is negative 5. We just took out the negative 1 common. So this would give you 5v square minus 17v plus 6. And we can factor it out like we regularly do. So we'll get v minus 3, 5v minus 2, and which can be written as minus v minus 3, 5v minus 2. So that was one. If you have like a leading coefficient is negative, so you just take out the factor. Now we'll go over finding zeros. So finding zeros. So this is the question, find all real zeros of the function. So we already have it in the factored form, right? We just need to find the zeros. So to find the zeros, we equate the function to 0, and then we find out all the possibilities when the functions would be 0. So we have 5x, x minus 4 whole square. Sorry. Give me a second, sorry. All right. So we have 5x, x minus 4 whole square, and x minus 2 whole square equals to 0. What we can do here is equate it to 0, and we have three possibilities. So if the product is equals to 0, at least one of the factors must be equals to 0, because 0 multiplied with anything gives you a 0, right? So we have, so there are three possibilities here. We have, it can be 5x equals to 0, it can be x minus 4 whole square equals to 0, or it can be x minus 2 whole square equals to 0. So these are our three possibilities. If 5x equals to 0, x would be equals to 0. If x minus 4 whole square equals to 0, x minus 4 would be equal to 0, and then x would be equals to 4. And if we have x minus 2 whole square equals to 0, then x minus 2 would be 0, which would give you x equals to 2. So the three possible zeros of the function are 0, 4, and 2. So this is how you find all the zeros of a function. You just equate everything to 0 and try to find out all the possibilities when the equation would be 0. So I have one question for you right here, and you can try it, and then we can discuss the solution real quick.
Nidhi, I think the
We
answer
have,
is in the chat. We can go over.
yeah, it's 0, minus 7, and 7. Okay. So yeah, that's the correct thing. So we have minus, so there are three possibilities again, minus 2x equals to 0, x square minus 49 equals to 0, and x minus 7 equals to 0. So if this is the value, minus 2x equals to 0, we get x equals to 0. If x square equals to 49, then we get x equals to plus and minus 7. And if we have x minus 7 equals to 0, we get x equals to 7. So here we have an intersection, right? Here also we are getting plus 7, and here also. So we just need to include it once. So our solution would be 0, 7, and negative 7. So now we'll do a factoring a constant one out there, like I was saying. So like if you have a number that is common in all the three terms, we can take it out common and make a simpler equation so that we can solve it faster. So if you see this one, it is little difficult to solve, like it is little difficult to find the middle term split up thing. But if you factor out the three common from here, we can get a much simpler equation and we can solve that one easily. So let's see the solution for this one. So if we have 3x squared plus 39 minus 90, we can factor the 3 out because that is the greatest common factor. And if we take out the 3, it would be x squared plus 13x minus 30. And this is the simple equation that we are used to solving now. And so if we solve this, we would get x minus 2 and x plus 15. So by just factoring a common thing out, you can make the equation much more simpler and solve it a bit faster. So that was another one. Now we'll just go over some basic math identities. So these are some identities that you need to remember, and it will be really useful throughout your algebra and calculus classes. So the first one is a plus b whole square, which is a square plus b square plus 2ab. The next is a minus b whole square, which is a square plus b square minus 2ab. So there's a little difference. It's plus 2ab and minus 2ab. And the another one is a square minus b square, which is a plus b and a minus b. So these are this equation can be used in like different forms. So if sometimes you have it in this format and you change it to this one, and sometimes you have it in this format and you are required to change it in this form. So this is also a very useful identity. Now we can go over some examples on these identities. So what if we have x plus 2 whole square? So we learned that a square plus b square plus 2ab. So I just use that identity, a square plus b square plus 2 times x into 2. Now we solve that, we'd get x square plus 4 plus 4x, which is, this is just basically how it is written from highest power to lowest power. So we just write it as x square plus 4x plus 4. What if we have like x minus 2 whole square? So here is just a simple difference. It's instead of plus 2ab, we have minus 2ab. So it's a square plus b square minus 2ab. So it would be x square plus 4x minus 4x. And again, to write it in the usual form, we do x square minus 4x plus 4. And here I have some more, a more harder type of a question for you. So what if we have 5 plus 1 whole square minus 64 equals to 0? So we need to find, simplify our answer, and we need to find the value of y. So first we'll write it in the square form. So if we have like y plus 1 whole square, we just take 65 to the other side and make it y plus 1 whole square equals to 64. And note that this equation is in the form of a square equals to n, where n is some positive integer. And when it is in that form, we have two solutions, right? A can be equals to root n, and it can be equals to negative root n, because the square of negative root n gives you n again, like n square again. So for the current problem, we have y plus 1 equals to 64 and y plus 1 equals to negative 64. So when we simplify those two like separately, we get y plus 1 equals to 64, y plus 1 equals to 8, because 64 is the under root of, like 8 is the square of 64. 64 is the square of 8. So y plus 1 equals to 8, and we get y equals to 7. And if we do the negative one, we get y plus 1 equals to negative 64, and y plus 1 equals to negative 8, which will give you y equals to negative 9. So these are the two solutions for this equation right here. So I have one for you. You can try this one out, and then we can go over the solutions.
I can't type this in, but let's see.
Yeah, can you just, do you want to?
Let me just, oh, well, here we go. Yes, I believe the answer would be negative 9 plus or minus 4 root 2.
Okay, so we can go over that real quick. Negative 9 plus or minus 4 root 2. That is the correct one. So what we did here is the same thing. We just equated it to 32. 32 is not a perfect square of something, so that's why we get like 4 root 2. And then you just take the take plus 9 to this side. So we get v equals to negative 9 plus 4 root 2, and v equals to negative 9 minus 4 root 2. So that was it. Now we learned factoring quadratic equations, basic math identities, finding zeros, and we did examples on the identities.